Welcome back the online classes by Konnur institutions. Hope you all are watching videos. In last class we were discussing about the solubility of gas in a liquid, that is explained on the basis of Henry's law, very important. And also we were discussing the factors affecting the solubility of a gas in a liquid, that is the nature of the solute and the solvent, or the nature of gas and the solvent. All the gases doesn't having the same solubility in a different solvent and the same solvents also, and all the solvents doesn't having a solubility of dissolving gases like oxygen and HCl and NH3. We were discussing that depends on the nature of the gas and solvent. Polar gases will having a more solubility in water, and those polar gases will not are having a less solubility in benzene or toluene like CCl4. And also we are discussing effect of temperature also. So effect of temperature, regarding that solubility and temperature are inversely proportional to each other according to the Leach-Layer principle. We were discussing that, so that we have to remember those are inversely proportional to each other. And one more factor which affect the solubility of gas in a liquid is very important, that is effect of pressure. That effect of pressure is based on the Henry's law we were discussing. Henry's law statement will be the what? Partial vapor pressure of the solution gas above the solution is directly proportional to the mole fraction of the gas in the solution. P is directly proportional to the mole fraction. So that solubility of a gas in a liquid can be expressed in the form of mole fraction we are discussing. And also, so regarding that P is equal to Kh into X, we will get full fraction of the gas. Kh is a Henry's constant. That Kh having a different value for the different gases, and Kh value and solubility are inversely proportional to each other. If the more the Kh value, lesser the solubility will be there, and temperature versus solubility inversely proportional to each other. And also we were discussing applications of the Henry's law. Regarding that Henry's law will apply in the production of carbonated beverages. So soda bottle or bottles are sealed under high pressure. In that carbon dioxide is dissolved in the solvent. And also scuba divers, when they move towards the deep of the ocean or sea, they will their more pressure will be there. Hence the more amount of gas is soluble in the blood. While coming back towards the surface, pressure will be decreases, soluble gases will come out of the blood cells. Such cases, those will block the capillaries, so that symptoms in the medical word is called as a bends. And also, when the climbers move towards the altitudes, pressure will be decreases, so low concentration of oxygen leads to the climbers, they are not thinking properly and they will get the sickness. That symptoms in the medical word is called as a anoxia. These are the important application of the Henry's law. So in today's class we will discuss about the one more important term, that is vapor pressure. It's very important term, vapor pressure. So using this vapor pressure we will discuss in the colligative properties also. So first we need to know what is the meaning of the vapor pressure, how it will be created. So now we will explain that. So vapor pressure means, before going to that let us take the solution is taken in a closed vessel. The solvent or the pure solvent taken in a closed vessel. So this is a solvent, liquid, water, you can imagine. So this liquid, half of the vessel is filled up with the liquid. These are the liquid molecules situated at the surface of the solvent. When the liquid is allowed to evaporate, some of the liquid is converted into vapor molecules. Evaporation means this will be evaporate to form the vapor molecules. These molecules present at the surface of the solution having the tendency to escape from the liquid phase to vapor phase, because those are having a more kinetic energy. So these molecules will convert it into vapor. Here vapor molecules are collected over the solution. So because of the closed container, these vapor molecules will not escape out from the vessel. These vapor molecules are collected over the solution. As the evaporation process is increases, the vaporization is also increases, or that is the vapor molecules are also increases over the solution. If the molecules are increases at the vapor phase, these molecules are called as the gaseous molecules. Vapor is also called as the gaseous molecules. Those are moving randomly. As we already discussed in the last year kinetic theory of gases in states of matter. So those are moving randomly. When these vapor molecules are moving, they will collide each other, and those molecules will hit to the wall of the container, and also those molecules when the strike to the surface of the solution, the condensation will occur. These vapor molecules are converted into again liquid. When these vapor molecules are strike to the surface of the liquid, they will exert a pressure on the surface of the liquid. They will exert the pressure on the surface of the liquid. This pressure is called as the vapor pressure of the liquid. Hope you all understand this point. As the solution is allowed to evaporate, as the evaporation is increases, the vapor molecules over the solution is increases. If the vapor molecules are increases, means those vapor molecules are randomly moving, they will collide each other, and also they will strike to the wall of the container, and also those vapor molecules when those are strike to the surface of the liquid, those will exert a pressure on the surface of the liquid. That pressure is termed as a vapor pressure of the liquid at equilibrium, we call it. So at the initial, when we had taken a liquid in the closed vessel, so the evaporation process will be there. There is no vaporization. So after some time, this liquid start evaporate and the vapor molecules are collected over the solution. After some time, when the vapor molecules are increases at the vapor phase, those molecules will strike to the surface and converted into liquid. So that is a rate of vaporization or evaporation. Rate of evaporation is are at equilibrium with the rate of condensation. Rate of condensation. So these are in dynamic equilibrium. What is the meaning of this one? So rate of evaporation means a number of molecules are escaping from the solution. So those are equal to the number of vapor molecules are converted into liquid. So those are equal. It means the equilibrium not only almost same it is. It may not be the 10-10. It may be the 100-90. It may be the 90-10. It may be the 80-20. It may be the 60-40 like that. So equilibrium attained between the rate of evaporation and rate of condensation. In such condition, whatever the pressure created by this vapor is known as the vapor pressure of the liquid. How to define this one? So vapor pressure of the liquid. Vapor pressure is equal to the pressure exerted by vapor of liquid at equilibrium is called as vapor pressure. We call very important point. You have to remember vapor pressure. And the important points regarding the vapor pressure we have to remember. Always the vapor pressure of the solvent is less than 1 atmospheric pressure. Always the vapor pressure of any solvent is less than 1 atm pressure. So what happens if the temperature increases? Now we will discuss that. If the temperature increases, if we give the temperature to this one, the number of molecules escaping from the liquid surface to the vapor phase will be increases. It means the evaporation process will be increases. as the evaporation process increases, number of vapor molecules over the solution is also increases. It means so as the temperature increases, evaporation process increases, vapor molecules are increases. Those vapor molecules will exert a pressure on the surface of the liquid. Hence, there is more vapor pressure. It means what? Vapor pressure is directly proportional to the what? Temperature. As the temperature increases, vapor pressure of the solution over the liquid is also increases. You have to remember one more point. And when the liquid having a weak intermolecular force of attraction is more volatile and having a more vapor pressure, as we already know that. So that is a vapor pressure versus volatile. What is the meaning of the volatile here? Volatile in the sense that component will be start evaporate or vapor phase. So it will convert it into liquid into vapor. That we call as a volatile. Example, you can take a petrol, you can take, that is more volatile, and you can take the diesel, that is also more volatile compared to the water. Even though if you have taken a water, that will be evaporated at the room temperature. So volatile in the sense that. So volatility is directly proportional to the what? Vapor pressure. If the liquid having a more volatile nature means more vapor pressure will come. It means more vapor molecules are formed. Those vapor molecules will exert a pressure. More vapor pressure will be created. And one more point regarding that, you can remember, vapor pressure is inversely proportional to the boiling point. Very important point. Vapor pressure is inversely proportional to the boiling point. Example, ethyl alcohol and water you can take. So ethyl alcohol having a boiling point 78.3 degrees Celsius and boiling point of water is 100 degrees Celsius. So now according to this one, vapor pressure is inversely proportional to the boiling point. Lesser the boiling point, more the vapor pressure will be there. Among these two, ethyl alcohol having a more vapor pressure, because having a less boiling point, and vapor pressure of the water compared to this ethyl alcohol is what it is? Less, because 100 degree our boiling point is more. What happens if the boiling point is less means intermolecular force of attraction between the molecules will be weak or less. So those molecules will easily evaporate and form the vapor state or vapor molecules. Those vapor molecules easily, if it is evaporation taking place, means more vapor molecules are formed. More vapor molecules will exert more pressure on the surface of the liquid. Hence the vapor pressure of the liquid is increases if the boiling point is decreases. So this is the point you can remember regarding the vapor pressure. So now we will discuss about the vapor pressure of liquid solution and also vapor pressure of solid in liquid we will discuss now. Yes sir. Now we will discuss about the vapor pressure of liquid solution and later we will discuss about the vapor pressure of solid in liquid solutions. Coming to the point, liquid solution. Here the solute is also liquid. Solute plus solvent leads to the formation of solution. Solution will form. Among the solution, the components like solute and the solvent. Solute is also liquid and the solvent is also liquid. So these two liquids are volatile in nature. These two liquids are volatile in nature. Volatility means those substance of the liquid will evaporate easily. So those will form the vapor molecules over the solution. So those two, nature of the solute and the solvent are volatile. Consider the one volatile component of the mixture. If you take the binary mixture or the binary solution, means the solution containing two components, one is a liquid, another one is also liquid. Consider the one component in a closed container. If you take the closed container, then only the equilibrium will be reached, or else the vapor molecules are go out of the vessel, the equilibrium will not be reached. So when we have taken a pure component in a closed vessel, so this is, you can call as component number 1. Component 1. This is volatile liquid. When we have taken the solution in a closed container, the solution the solvent will start evaporation. So these vapor molecules are collected over the solution. These vapor molecules will having a more kinetic energy. They will move each other. So one kinetic, if the kinetic energy increases, these two vapor molecules are collide each other, and also those vapor molecules are exert a pressure on the surface of the liquid. That pressure is known as the vapor pressure of the liquid. Say this is the pure component, hence the vapor pressure of this one is measured as P1 naught. Here the naught indicates that the vapor pressure of the pure component. Only one component we had taken, so that is indicates the naught. That is what? Vapor pressure of pure component 1. Pure component 1. And this vapor pressure having a mole fraction x1 here. This is the component number 1, and we will take the one more volatile liquid. One more volatile liquid. So that is also taken a closed container. When the second pure component is allowed to evaporate, so the part of the liquid will be evaporate, will form the vapors on the surface of the liquid. Same. These vapor molecules are the evaporation process is increases. Vapor molecules are also increases. These vapor molecules will exert a pressure on the surface of the liquid. That pressure is also called as vapor pressure of this liquid. This is the pure component. This is component number 2. Component number 2. So this pressure is denoted by the P2 naught. So this P2 indicates what it is? Pure vapor pressure or vapor pressure of pure component 2. This indicates that we can take here P2 naught, vapor pressure of pure component 2. When these two volatile liquids, this is also volatile in nature. Volatile in nature. So these volatile liquids, when we add solute and the solvent, solution will be formed. So these are the solution. This P2 not having a mole fraction x2. P2 not having a mole fraction S2. So now when we add the first component and the second component, the solution will be formed. This solution having two components, component number 1 and component number 2. When the solution will evaporate to form the vapor molecules over the solution, same here, vapor molecules are collected over the solution. This vapor is called as a P1 partial vapor pressure of a first component and P2 partial vapor pressure of a second component, and also mole fraction of that one is x1 and x2 will be there. Now according to this one, that the vapor pressure of liquid solution can be explained on the basis of Raoult's law. Then what is the statement of the Raoult's law now we discuss? So that is Raoult's law. As we already discussed the Henry's law, there also partial vapor pressure of the solution is directly proportional to the mole fraction. But in case of that, gas will be soluble in the liquid. Here also same it is. Vapor pressure is directly proportional to the mole fraction. But here we have taken both the volatile liquids, there we have taken a gas. Here also this partial vapor pressure of this one is directly proportional to the H2. What he tell that his relationship between the Raoult's law explain about the relationship between vapor pressure and mole fraction. Vapor pressure and mole fraction. So what is the statement of the Raoult's law? I will write here. The partial vapor pressure of the each component. This is the partial vapor pressure. Partial vapor pressure of each component is directly proportional to the mole fraction of the component in the solution. Here also same, two components are there. Partial vapor pressure of each component is directly proportional to the mole fraction of the solution. So that is the Raoult's law. How to define this one? Or statement of the Raoult's law. The partial vapor pressure of each component is directly proportional to the mole fraction of solution. So that is the partial vapor pressure of each component is directly proportional to the mole fraction of the solution. It means what? Here if the more number of moles are there, that much number of moles will evaporate to form the vapor molecules. That's it. So it is depends on this one, number of moles. More the number of moles in the solution will be there in the form of mole fraction. We are expressing that. More the number of moles, those number of moles will evaporate to form the vapor pressure. Those vapor molecules will exert a pressure on the solution. That will termed as a vapor pressure. We know that. So now how to write in a mathematical form? That is the partial vapor pressure of, for the component 1 you can take, for component 1, that is partial vapor pressure of one component. First component we are writing, partial vapor pressure of first component is directly proportional to the mole fraction of the component. That is P1 is directly proportional to the mole fraction of first component. Now we can write this one. P1 is equal to P1 naught into X1. If you remove the directly proportional sign, one constant will come, that is a P1 naught. So now for the component 2 you can take. For component 2, that is partial vapor pressure of the second component is directly proportional to the mole fraction of that second one. So that is P2 is directly proportional to the X2. Now P2 is equal to P2 naught into X2. This is equation number 1 you can take. This is equation number 2. P1 and P2. In the last year we were discussing about the Dalton's law of partial pressure. According to that, if you want to calculate the total vapor pressure of the solution, this is the binary solution. Binary solution containing what it is? Containing two volatile liquids. If you want the total vapor pressure of the solution, we have to do the sum of the partial pressure of each component. Here we are having two components, hence we have to do the P1 plus P2 if you want the total vapor pressure of the solution. According to the Dalton's law, we will do that. P of total means total pressure is equal to sum of the partial pressure of first component and second component we have to do. Yes, according to the Dalton's law of partial pressure. According to Dalton's law, total pressure of the solution is equal to sum of the partial pressure of components, that is the P1 and P2. Sum of the components are P1 plus P2. We already derived P1 is equal to P1 naught into X1 P2 is equal to P2 naught into x2. Now it is P1 is equal to P1 naught into x1 plus P2 is equal to P2 naught into x2. Here the P1 naught is constant and P2 naught is also constant. Now we can P1 naught into x1 is equal to how to write? Sum of the mole fraction of all the component is x1 plus x2 is equal to 1. So now x1 is equal to 1 minus x2. x1 is equal to 1 minus x2. Put this x1 value here. x1 is equal to 1 minus x2 plus P2 naught into x2. Now multiply this one. P1 naught minus P1 naught into x2 plus P2 naught into x2. Here x2 common. You can take the common x2 and that is P2 naught minus P1 naught. So now it is P1 naught plus I will write this one. So that is P2 naught minus P1 naught. So x2 is the common. So that is what P total is equal to P1 naught plus P2 naught minus P1 naught into x2. This is the mathematical formula for the Raoult's law having the two volatile liquids. Mathematical formula for Raoult's law. You have to remember, later we will discuss this one in a problems also, numerical problems. There is a P total if you want to calculate, or the pure component vapor pressure if you want to calculate. So now we will discuss about the vapor pressure versus mole fraction graph, how it will be. There are two components in the solution. Hope you will understand what I am telling here. Vapor pressure of liquid solution means both the solid and the solvent are the liquid. So if you have taken a pure component, one component vapor pressure will be there, that can be denoted by the P1 naught. Here the P1 naught means what it is? P1 naught means vapor pressure of pure component. P1 is the partial vapor pressure, P1 naught is the naught indicates that pure vapor pressure of the component. That's it. So now we discuss the graph between the what it is mole fraction, graph between mole fraction versus vapor pressure. There are two components. So now this is a vapor pressure, this is a mole fraction. There are two components. We have to draw in a one graph only. That is one more exercise. First component, that is P1. So if it is P1 means it starts with the origin. When the P1 will be P1 is 0 means what about the x1 according to the equation? If the P1 is 0 means x1 is also 0. So that first component x1 is equal to 0. So when the mole fraction or the number of moles are more means so vapor pressure is also more. Hence we will get the straight line. So mole fraction or the number of moles are increases. Vapor pressure of the component is also increases. Maximum value of this P1 will be P1 naught. Vapor pressure of that one will be maximum P1 naught value. When the P1 naught value is maximum means, so that is when it will become a P1 is equal to P1 naught. Coming to the point here, so you can remember. Now, when the P1 will becomes P1 naught, when the x1 is equal to 1 means P1 will become a P1 naught. Hope you understand this point. So when it is x1 is equal to 1 means in such cases P1 is equal to P1 naught. P1 is equal to P1 naught. So here means as it is. So now mole fraction of x1 is equal to what? 1. So it will be increases and vapor pressure is also increases. This is the first component graph. And second component graph starts with the origin. It means x2 is equal to 0. Second component mole fraction will be 0. If it is mole fraction is number of moles are means more means, so that is vapor pressure is also increases. How much the maximum value? That is P2 naught maximum value. When it will become P2 will become P2 naught, second equation. So now it is P2 is equal to P2 naught into x2. When the P2 will become P2 naught, when x2 is equal to 1. So when x2 is equal to 1 means P2 will become a P2 naught. So now mole fraction of the second component is 1/. Or you can check the sum of the mole fraction of all the components in the solution is equal to unity. 1 plus 0 is equal to 1. Sum of the mole fraction of components in the solution is equal to unity. So this is the two graph of two components. If you want the total vapor pressure of the solution, what you have to do? We have to do the sum of the partial vapor pressure of the components present in the solution. So we have to do these two sum. If you do these two sum means we will get the total vapor pressure of the solution. So that is P total is equal to P1 plus P2. This is a very important graph. Hope you all understand this one. There are two components in the solution. Both are volatile. Those components starts with the 0. First one. If it is a 0 means P1 is 0 means when P1 is directly proportional to x1 according to the mathematical form, P1 is 0 means x1 is also 0, hence we have to take the x1. At this side, x1 is increases. X1 is increases. Number of mole fraction of first component is increases. If number of moles is increases means vapor pressure is also increases, hence we are getting a straight line here. How much maximum value it is? That will get the P1 naught maximum value. When the P1 is equal to P1 naught according to mathematical formula, when x1 is equal to 1 means P1 is equal to P1 naught. Hence we have to write the x1 is equal to 0 and x1 is equal to 1. Second component starts with the origin P2, so that mole fraction is increases, x2 will be increases this side, and mole fraction is increases means vapor pressure is also increases. So maximum value will be P2 naught. So when it will become P2 is equal to P2 naught, when x2 is equal to 1 means P2 will become a P2 naught. So that we are writing x2 is equal to 1. Or you can check that total number of sum of the mole fraction of all the components will be 1. Sum of the mole fraction of all the components will be 1. So if you want the total vapor pressure of the solution, we have to do the P total is equal to P1 plus P2. And one more point you can remember regarding so we have taken a solution, the solution containing two non-volatile liquids, that is the x1 and x2 are the mole fractions of two component, and P1 and P2 are the partial vapor pressure of the two components. So when these liquids evaporate to form the vapor here, so if you want to calculate the mole fraction of these x1 and x2 in vapor phase, that can be denoted by the y1 mole fraction in vapor phase of the first component and the mole fraction of the vapor phase of the second component. Then it means y1 and y2 are the mole fractions of components in a vapor phase. You have to remember one more point. So this y1 and y2 are mole fractions in vapor phase. So this is the vapor pressure of liquid solution. Overall what it is, when we add the two non-volatile liquids, what about the total vapor pressure of the solution? Whether we have to do the sum or what you have to do. Now already we discussed that one. In the next class we discuss about the vapor pressure of solid in liquid containing non-volatile solute volatile solvent. So in the next class we will see that one. So thank you.